Hey, welcome back, and this is called Find Words That Can Be Formed by Characters. And so here we're given a array of words here, so cat, BT, hat, and tree. And then we're also given a string of characters, which is essentially like an array of characters. They just put it in a string to see that which words in this array of words can we form using these characters. And so in this case, cat, well, we can form that with C, A, and T. We can't form this word because we don't have B. Hat we can form with H, A, and T. And then tree we can't because we don't have E or R. Now, there's two caveats with this. One of them is that we can only use these letters once. And so say cat was spelt like C-A-A-A-T. Well, we only have two A's, so we can't form that. And then the other thing is our answer is a little weird. We're returning an integer and it's equal to the lengths of the words we can form. And so cat is the length of 3, and then hat has 3 letters in it. And so 3 plus 3 is 6. So kind of a weird answer. The question doesn't make much sense, but we're going to implement it. So what we'll first create is our sum. And this will be the sum of the lengths, which is our answer. And then next, we're also going to have a Boolean value called isValid. And we'll initially set this to true. And this will be used so that just for temporary variable checking, okay, can we use these letters to form each particular word? And so next, what we're going to use is actually a direct access array. And a direct access array is something that you often use for a lot of these string questions where you want to say, okay, at, array A. And so essentially you want the letter A to be representing the index location 0. And so it's often used so you can say, okay, I've seen A before, then increment that location. So you basically use the index location as the letter value. So A is actually equal to the integer equivalent, I believe, of 76. And so really this would be 76 at this index location, but you want to say minus A. And so that would be then 0. And then so then B would be 77, which is really like B minus A. So then that would be at stored in index location 1. Okay, so if that doesn't make much sense, I think it'll make a little bit more sense in a second. So let's go ahead and try that. So we'll have an integer array, and we'll call this words, or no, we'll call it letters, and it'll be equal to a size of 26 because there's 26 letters in the alphabet. And then we're going to use a for loop. And we'll iterate by 1 each iteration. And so we'll be just using this so that we can set these values. So letters at the characters dot character at I. We'll iterate by 1. And so in this case, it would look like this. We'd have an array here of length like 26. And so first for like index location 0, it would be 1. And then index location T, I don't know what letter T is in the alphabet, but let's just say like 0, 0, 0, 0, 0, 0, 0, 0, 0 until the letter T, let's just say it's like the 16th letter in the alphabet. We would set that to 1, and then we'll go back to A and say, okay, at index location here, we'll increment that to 2, and etc. So you basically have an array of the counts of the letter occurrences. And so the other thing that we have to do is, once again, minus A, because A, the integer equivalent is 76, not 0, and we want A to be 0. So next, we want to actually clone this. And so we're going to say int original is equal to letters.clone. And so we're essentially taking this as the original letters. So you can't really just say original is equal to letters, because you're getting the memory location and not the exact values of that's being stored here. And so you want to be using a clone of it. And the reason we want this clone is because we're going to be decrementing the count for each iteration. And so for the letter A in this, like for C, we'll say, okay, at index location C minus that. And so the letter occurrence is now from 1 to 0. Then A, at index location A, it goes from 2, because there's 2 occurrences, down to 1. And say if we saw it again, then we would subtract it again and bring it down to 0. And so we're basically checking if for this example, we check at index location letters 1. If this is equal to 0, we want to return, like, then it's not valid. Is valid is false. Is false because, well, it never got incremented in this array, so therefore we don't have that letter. Okay, so we'll go ahead and implement that. Might make more sense when you see the code. So we're just iterating through each word in our list. And then once again, we want to iterate through each letter within each word. And so it's not O(n) squared, it would be O of n, because it's O of n in terms of the character length. And so I would say in this case it is O of n, because O of n, where n is the number of letters of all the words. So we'll just change this to j. And then also we want to check at index I, so the ith word, and we want the character at j. Or no, we just want the length here. So because the word is a string, we want the length with brackets. While when we're dealing with an array, we don't need the brackets. Okay, and so next we want to check. So if let's see here. If the letters for the word at the ith location, the character at j minus a. Yeah, so for this word that we're currently looking at, so for each word, and then this will be letter in word, for every letter in the word. So for the jth word in the word I, and then because we're doing the direct access array, we want a minus a. So for B, it would be like B is equal to 77, and then A is equal to 76, and so that would be at index location 1. So if this is 0, then we want to set is valid to false. And then afterwards, we want to decrement that array. And so one thing we can do just for optimizing it is if it's false, we'll also break here. And so we don't keep checking through all the words or through every letter in that word if we already know that it's not valid. So after this, what we're going to do is we want to check if it's valid, and if so, we want to increment our sum with the length of that word. So if it's valid, then we want to set our sum equal to that word's length. So after that, we also want to set is valid to true, because if it got set to false here, we want to reset it to true each iteration. And then we also want to, let's see here. We want to clone this letters array. So the original clone. And so this just resets all the values because we were just decrementing all the our letters array with each iteration. So we just want to reset it to the original count of the letters. And let's just see here. I think it makes sense. Let's just see if there's any errors. Yep. Yeah, we need a bracket here. What else? Okay, we gotta take a look at this. Letters is equal to, now we have one extra. And let's see here. Word, so I don't think it's word, it's words. And a lot of little things. Once again, words, I must copy that over. And then once again, clearly I used, try submitting it. And success. So let's go ahead and kind of look at our solution one more time. So it's quite performant. I would say it's O of n, where n is the number of letters in all of the words. And then we also are making use of this clone, which is really important to remember that. I think this is one of the most well-used array methods that you can have. What else here? I think one little caveat that I always miss is these brackets when you're dealing with an array versus when you're dealing with a string. So when you think string, use brackets. When it's array, don't use them. And yeah, this direct access array, to remember to subtract a from it. That's a little thing that I always miss, where at location A, it's really, I think, 76. So you need to minus a from it to get 0. And I would say that's about it. So good question to practice. Makes you use the clone function, direct access array, and how to deal with that little caveat there. So yeah, I hope that helped, and good luck with the rest of your algorithms. Thank you.